All right, so we're at topic 4B in probability, math 30-2. So we're continuing to talk about dependent events, and we're talking about conditional probability. So our goal in this lesson is to understand and solve conditional probability problems. So what we learned in the previous lesson, we learned about independent and dependent events. And dependent events are two events in which the outcome of the first event does affect the outcome of the second event. So if you're pulling a marble out of a bag, when you pull a marble out, if you don't replace it, the total number of marbles changes, as well as the number of that particular color of marble. Now, the probability that two dependent events will both occur can be calculated using the product rule. So it's important to note that this P, B / A, that's the probability of B happening if A has already happened, okay? Now, and this is the notation we also use for conditional probability. Now, conditional probability is the probability of an event occurring given that another event has already occurred. And we can use this formula. So you see, it's just a rearranging. If we know the probability of A and B, and we divide it by the probability of A, that will give us our probability of B if A has already happened. Okay, so this is probability of B if A has happened. Okay, so that's the condition. All right, so let's look at a few examples. Calculating conditional probability using a Venn diagram. So we can use a Venn diagram to help us determine this. So good thing we've done set theory, and good thing this reviews that for us. So Riel chooses a number between 1 and 15 that is a multiple of 4. He wants to figure out the probability that the number is also a multiple of 6. So he defines his universal set and the events as follows. U is all natural numbers from 1 to 15 inclusive. So if we write that set out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. F is the multiples of 4 from 1 to 15 inclusive. So 4, 8, 12, and I think we're done because if one more multiple of 4 would be 16. And S is the multiples of 6 from 1 to 15 exclusive. So that would be 6 and 12. Now, we've got our elements of our set. Now we're going to use a Venn diagram to help us kind of organize and assess the situation. So we'll draw our Venn diagram. The universal set is there. In it, we have F and we have S. Now in F, we have 4 and 8 and 12 in the middle because 12 is in both F and S, and 6 here. In the rest, we have 1, 2, 3, 5, 7, 9, 10, 11, 13, 14, 15, 17, 18. No, I went too far. I got carried away. These do not exist because it's only 1 to 50. All right. Sorry about that, folks. So we know from this, and we can do some little coloring. This is F, which is our multiples of 4. And this is S, which is our multiple of 6. So we can use that Venn diagram to kind of help us answer some questions. So, determine the probability that Riel's number is also a multiple of 6 using the Venn diagram from above. So, if we look at that Venn diagram from above, we know he's pulled a multiple of 4. So that was the probability of F, right? And so the probability of S, so multiple of 6, if he's pulled a probability, he's already pulled a 4, is going to be, so looking at our total numbers, is going to be 1 out of 3. Because there is only one multiple of 6 that is also a multiple of 4. So we're really only, if we're thinking about it, we're only caring about what's in the red. And for the blue, that's just going to be our number of positive answers. Okay? So we can use that Venn diagram to kind of help us sort out our probability. Let's do some more examples. Calculating the conditional probability using a tree diagram. And these work specifically really well when we have percentages. So Hillary is the coach of a junior ultimate team. Based on the team's record, it has a 60% chance of winning on calm days and a 70% chance of winning on windy days. Tomorrow there is a 40% chance of high wins. There are no ties in ultimate. Determine the probability of a calm day tomorrow. Well, there's a 40% chance of high wins. So remember, if it's a percentage, it's got to add up to 100. So that means it's 60% chance a calm day. So we're going to transfer this information to parts A and B onto the tree diagram, labeling all the branches with the appropriate probabilities. So first we're starting with the weather. There is 0.6, right? That's the decimal form of it being calm, and 0.4 of it being windy. All right? Now, if it's calm, they have a 60% chance of winning. So that would be 0.6 to win. The complement of 0.6 is 0.4. So if it's calm tomorrow, they have a 0.4 chance to lose. If it's windy, there is a 70% chance of winning, so 0.7 to win. And the complement to 0.7 is 0.3. It has to add up to 1. So to lose. So to figure out the probability, we just multiply. So here we'll go 0.6 times 0.6 equals 0.36. To have it be calm and then lose, it will be 0.6 times 0.4, which equals to 0.24. To have it be windy and win, it will be 0.4 times 0.7, which adds up to 0.28. And have it be windy and lose, it's 0.4 times 0.3, which is 0.12. Now here's the neat thing, you add all those up, equals 1. All right? Because your probability always has to add up to 1. Okay? You can test that out. So we've done C. We've calculated all those probabilities. That's what we did up there, right? By multiplying what we got on the tree diagram. I think the big thing is that when you're given that one probability, like calm and windy, that you know that the complements have to come into play. Win and lose, we've got a 0.6. That means the opposite will be 0.4. So determine the probability that Hillary's team will win tomorrow. So looking at these, let's look where they win. They win here, so that's 0.36, and they win here. That's 0.028. So 0.36 plus 0.28 equals 0.64. Determine the probability that they'll lose. Well, they lose there, so that's 0.24, and they lose here, which is 0.12. So we're going to add those together. So we'll have 0.24 plus 0.12, which adds up to 0.36. Now, or you could have just, those two add up to 1.0, right? So you could just subtract 0.64 by 1 to get that answer, because it's going to always be the complement. All right? So the probability of them winning if it's calm, we can figure that out. Probability of them losing if it's calm. Winning if it's windy, or losing if they're windy. But we can figure out the overall probability for winning and losing just by separating those out. calculating conditional probability. So we're looking here. Probability that a long-term battery will last for 5 years is 0.75. So probability of 5 is 0.75. Probability that a battery will last for 6 years is 0.5. So probability of 6 equals 0.5. Suppose your battery lasted for 5 years. Explain why 5 and 6 is equal to 6. Because if it's lasted for 6, it would have had to have lasted for 5. Okay. Determine the probability that the battery will continue to last for 6 years. So we want to know the probability of 6 if it lasted for 5. So P, 5, and 6 divided by P, 5 equals P6 over P5, because these have to equal each other. So 0.5 divided by 0.75 equals 2/3. We've just reduced that. You can divide it. If you divide it, you're going to get 6.66 repeating, right? But it's easy enough to just put it in a fraction. Okay. So it's just understanding that if it's lasted 6 years, it lasted 5 years as well. So that's kind of a tricky thing. I've never seen a question like that before, so that's a good thing. Calculating conditional probability using a Venn diagram and the formula, so using both. So representatives from the Vida Vacation Club surveyed travelers flying to Puerto Vallarta from Canada. Their data revealed the following information. 30% of the travelers owned a timeshare somewhere in Mexico. 80% of the travelers had visited Puerto Vallarta before, and 18% had visited Puerto Vallarta before and own a timeshare. So we got our Venn diagram. So Puerto Vallarta, timeshare. We know that 18%, oops, I'm writing it in decimal form. I'm going to write it in percentage form. 18% have both, right? So that means that if they own a timeshare, it's 30% total. So 18 plus 12 equals 30, right? That'll give me a total of 30% there. And Puerto Vallarta, I like to say that, I've been there, is the total is 80. So 80 minus 18 is 62%. Okay, so we've done our little Venn diagram there. Now, a traveler who was selected at random had visited Puerto Vallarta before. Determine the probability that this person also owns a timeshare. So we want to know the probability that they own a timeshare if they've been to Puerto Vallarta before. So we're going to take, if we look at our formula, we're going to take the probability of A and B, I better write it, the actual terms we're using. PV and T divided by the probability of T. Or no, PV. Sorry. I want to make sure I get it right because it's kind of different when we switch names up. Okay, so we're using that formula. So probability of P and T is 18%, divided by the probability of PV, which is the whole big circle, 80. So that will be 9 over 40. We can also convert that to decimal if you'd like. 9 divided by 40 which is 0.225 or 22.5%. Sometimes it's good to get those examples of writing it in different ways. You never know on a multiple choice how it's going to be expressed, so getting used to converting them is not a bad idea. A traveler who was selected at random owns a timeshare. Determine the probability this person has also visited Puerto Vallarta before. So we are now looking for, okay, he visited, what is the probability that he visited Puerto Vallarta before and he owns a timeshare? So this is P, T, and PV divided by probability of the timeshare. So it's a little bit different. So on the top, it's the same amount because it's the and on the bottom, it is 30 because that's the total that owned the timeshare. So again, we can reduce this. This reduces to 3/5, which is the same as 0.6 or 60%. Far more likely if you to have somebody who visited Puerto Vallarta before also own a timeshare, okay? Or vice versa, sorry. It's good to map it out. The Venn diagram kind of helps you sort out the percentages. So it's good we did counting methods first, and then it's just applying that formula, okay? And that also is reinforcing some of our counting methods and set theory notation, your set notation. So it's a good review. So, need to knows. And I hope when we're doing these need to knows, you're going back and you're looking at vocabulary sheets at the beginning of the booklet and filling it in. Just doing that is a good way to study, but it's also to kind of sort out, did we cover everything that we needed to cover? And did you catch it all? So the probability that two dependent events will both occur can be calculated using this formula. P, A, and B is equal to P of A times P, B if A happened. Now, P, B / A is the probability that the second event, B, will occur given that the first event already occurred. So we know A happened. It's just now what's the probability B will happen. Conditional probability is the probability of an event occurring given that another event has already occurred. And we can use this formula, which is just a rearrangement. These are actually the exact same formulas, just rearranged. It's good to use things like tree diagrams. Those sports ones with the weather, I always use the tree diagram for those. And Venn diagrams also are very useful in terms of sorting things out, particularly with number sets and that example that we looked at. So take a look at that whenever you have one of those situations where you have an overlap. Then you want to make sure that you're using a Venn diagram to count for that. Okay, so they're very good for modeling those problems involving conditional probability. All right, so it's a little more practice with these. Enjoy. We got some practice pages to do, and probably